Hello there and welcome. I'm glad you found your way here. Maybe you had a long day feeling the full weight of the world. Maybe you're the kind of person who likes falling asleep to deep thoughts, to quiet wonders that gently untangle a busy mind. Either way, tonight's journey is for you. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light, as if gravity itself has softened its hold just for you. Because tonight, we will gently explore the most relaxing facts about gravity. We will drift through the invisible force that guides the cosmos, the quiet pull that holds worlds in their dance and gives, falling, its gentle grace. It is the architect of galaxies and the quiet hand that tucks you into bed. But beneath its simple presence lies profound mystery. We will wander from the gentle curve of space-time to the silent ripples that pass through everything. We will consider how a star's weight bends the path of light itself, and how the atoms in your body are held together by this same patient force. We will travel gently from the heart of a black hole to the drift of a feather, all held within the same universal embrace. Some of what you hear may surprise you, or at least spark a soft curiosity as you drift off. And just before we begin, if these calm explorations help you unwind, consider liking and subscribing. It helps other sleepy souls find their way here too, one quiet mind at a time. Now let's begin. The gentle architect gravity is not a force of violent attraction, but a patient tendency. An object with mass does not actively pull on others. Instead, it gently tells the space around it how to curve. And other objects, simply by existing, follow that soft curvature. It is less a tug and more like a marble rolling slowly down the gentle slope of a wide silk pillow. We do not fully know why mass and energy create this curvature in the fabric of the universe. It is a fundamental conversation written into the laws of reality. What we do know is that this curvature is what we feel as weight and what we see as orbit. It is a silent, continuous process, happening all the time, in every place where something exists. The apple that may have inspired Newton did not suddenly fall. It had always been falling from the moment the tree began to grow. Gravity is not an event that begins, but a condition that persists. The apple was simply released from its temporary anchor, and it followed the invisible path it had been poised to take all along, a path leading patiently downward. This is the nature of gravitational acceleration. It is a slow and steady gathering of speed, a quiet persuasion toward the Earth's center. There is no rush in its pull, only a constant and gentle insistence. Over the distance of a branch, it creates only a soft thud, a quiet return to the source from which the tree first drew its nourishment. Gravity is the weakest of the universe's four fundamental forces, a quiet whisper against the roar of the others. The tiny magnet on your refrigerator can lift a paperclip, defiantly overcoming the gravitational pull of the entire planet Earth. Its strength lies not in its power, but in its patience and its infinite range. It never turns off, never takes a break. It works slowly across impossible distances, gathering clouds of gas, shepherding stars, and weaving galaxies over billions of years. While other forces blaze and fade in an instant, gravity is the persistent background hum of the cosmos, the foundation upon which more fleeting dramas are played. We often imagine gravity as a force that only pulls things down, but in the cosmos there is no up or down. Gravity simply pulls things together. It is the great unifier, the force of connection. It draws dust to dust, star to star, and galaxy to galaxy in a slow, cosmic embrace that has lasted since the beginning of time. It is the architect of structure, from the delicate rings of Saturn to the vast, web-like filaments of galaxies that span the universe. Its language is one of attraction and orbit, a silent dance where every partner moves to the same timeless rhythm. It builds not with force, but with a gentle, unwavering persistence. The gravity you feel from the Earth is a collective pull, Every single particle in the planet, the iron in its core, the silicon in its mantle, the water in its oceans, contributes its own tiny, gentle whisper of attraction. All these whispers combine into the single, steady force that holds you to the ground. It is a force of community, a sum of countless tiny contributions. Even the atoms in your own body are pulling gently on the planet in a reciprocal agreement that defines your weight. This mutual attraction is so perfectly balanced, it feels like a simple, unchanging state of being, a quiet agreement between you and the world. Isaac Newton saw gravity as a mysterious action at a distance, a concept that troubled him. He could describe its effects with beautiful mathematics, but the how remained a profound mystery. It was a silent connection between bodies, with no visible strings or pushes, a gentle ghost in the cosmic machine. We now describe it as the curvature of spacetime, a concept that is in its own way just as mysterious. The how still gently eludes us. We can map its behavior, predict its motions, but the fundamental reason why mass bends the stage upon which it sits remains one of the universe's most quiet and profound secrets. Gravity cannot be shielded. You can block light with a curtain and stop magnetism with a piece of lead, but there is no material in the universe that can interrupt the soft whisper of gravity. It passes through everything, through walls, through planets, through you as if they were not even there. This is part of its gentle nature. It does not confront or combat. It simply permeates. As you lie in your bed, the gravitational pull of the stars passes through your ceiling, through your blanket, through your body, uninterrupted. You are immersed in an invisible, silent web of attraction, a participant in a cosmic conversation you cannot hear, but are always a part of. The cosmic dance in orbit is not a form of confinement, but a state of perfect, balanced falling. The moon is perpetually falling toward Earth, but its forward motion is just enough that it constantly misses. It falls around the world in a graceful, elliptical embrace that has lasted for billions of years. There is no struggle in this motion, only a serene and perpetual surrender to a curved path. This is the cosmic dance, set to a music of mathematics and momentum. The speed of the dancer and the strength of the pull find a quiet agreement, a harmony that results in a circle or a gentle oval repeated again and again. It is a flight without fuel, a journey without a destination, a perfect example of the universe's patient efficiency. The planets in our solar system do not race around the sun. They wander at a leisurely pace, each in its own time. Mercury, the innermost world, completes its swift year in just 88 Earth days. Meanwhile, distant Neptune takes almost 165 of our years to complete a single, slow circuit. This is Kepler's harmony, a law of orbital periods that plays out over vast stretches of time. There is no hurry in this grand procession. The solar system is a colossal clockwork with gears of planetary motion that turn with a slow, majestic patience. The planets we see tonight are simply in one moment of their long, looping journey, a journey that will continue quietly long after we are gone. We don't always see the true shape of an orbit, but many are not perfect circles. They are ellipses, gentle ovals where the central body sits not in the center, but at one of two quiet foci. This means a world like Earth is sometimes slightly closer to the Sun, and sometimes slightly farther away, in a slow, rhythmic breathing motion that defines our seasons. This eccentricity is a gentle variation in the cosmic dance. A planet moves a little faster when it is near its star, and a little slower when it is far, as if taking a deep, slow breath in the vastness of space. It is a subtle pulse in the system, a reminder that even in the heavens, perfection is found in gentle imperfection. The International Space Station seems to soar around the Earth, but it is, in fact, perpetually falling. It travels so quickly that the curve of its fall perfectly matches the curve of the Earth itself. The astronauts inside are in freefall, a state of continuous descent that feels, paradoxically, like weightlessness. They are not beyond Earth's gravity, they are embraced by it fully. They experience gravity not as a force holding them down, but as the shape of their path. They are dancing with the planet, moving fast enough to stay in its gentle grip without ever landing, a silent waltz at 17,000 miles per hour. Lagrange points are places in space where the gravitational pulls of two large bodies, like the Earth and the Sun, create a zone of perfect balance. Here, a smaller object can rest, almost parked, relative to the larger dancers. It is a gravitational haven, a calm eddy in the flowing river of orbital forces. The James Webb Space Telescope resides at such a point, 1,000,000 miles from Earth. It orbits not the Earth itself, but a point in space, a place of quiet equilibrium where it can gaze into the deep universe with minimal disturbance. It is a silent sentinel held in place by the gentle, balanced hands of gravity. Moons are the most intimate dancers, forever twirling around their parent planets. Our own moon is tidally locked, meaning it shows us only one face. Its rotation has slowed to perfectly match its orbit, a final, settled state in a long gravitational relationship. It is like a couple waltzing, always facing one another as they move through the ballroom of space. This locking is a gentle process, a gradual slowing over billions of years through the subtle, persistent pull of tides. It is a testament to gravity's patience, its ability to slowly synchronize motions until they become a single, harmonious unit, a quiet duet in the dark. The concept of escape velocity is not about violence, but about a gentle release. It is the slow, steady speed an object must achieve to softly unbind itself from a gravitational embrace. For Earth, this is about 25,000 miles per hour. It is the speed of farewell, the momentum required to begin a journey away from a celestial body without ever falling back. This does not mean gravity stops. Its whisper continues, growing fainter with every mile, but never truly vanishing. A spacecraft achieving this velocity is not breaking a chain, but slowly rolling up and over the lip of a hill, transitioning from a closed orbit to an open, wandering path among the stars. The fabric of space. Albert Einstein reimagined the universe not as a stage, but as a fabric. This fabric, spacetime, is a woven tapestry of 3 dimensions of space and 1 of time fused into a single, flexible entity. Mass does not pull on other masses across emptiness. Instead, it gently presses down upon this fabric, causing it to curve. Gravity, then, is simply the tendency for objects to follow the paths created by these curves. We do not know why the universe chose this particular geometry, this soft architecture. It remains a beautiful mystery, but we can observe its effects. A planet orbiting a star is not being pulled by an invisible string. It is simply rolling like a slow marble along the invisible groove that the star's weight has created in the cosmic cloth. Imagine space-time as a vast, still rubber sheet, stretched perfectly flat. Now place a heavy iron ball in its center. The sheet will dimple downward, creating a smooth, curved depression. This is what a star does to the space around it. The fabric itself is warped, and this warping is what we have come to call gravity. There is no force emanating from the ball. If you were to roll a smaller marble nearby, it would naturally trace a curved path around the depression, perhaps even spiraling in slowly. This simple model illustrates a profound truth. What we perceive as a force is really just the geometry of the space we are moving through, a gentle topography of attraction. One of the most beautiful predictions of this idea is gravitational time dilation. Time itself flows at different rates depending on the curvature of spacetime. Near a massive object, where the fabric is deeply curved, time flows more slowly relative to a place where the fabric is flatter. A clock at sea level will tick very slightly slower than a clock on a mountain peak. This is not a fault in the clock, but a property of time itself. Gravity does not just bend the paths of objects, it gently bends the flow of time. It is a slow, patient river, flowing at different speeds in different gravitational valleys, a phenomenon confirmed by the most precise atomic clocks we have built. The bending of starlight is one of the most ethereal proofs of this curved space. Light, which has no mass, still follows these geodesic paths. When starlight passes near a massive object like the Sun, it does not travel in a straight line. Instead, it follows the curve of the warped space, its path bending gently around the star. This means that the positions of stars we see near the Sun during an eclipse are subtly shifted. We are not seeing the star where it is, but where it appears to be, because its light has taken a curved journey to our eyes. It is as if we are looking at the world through a gently warped lens, a lens made of gravity itself. Black holes are not cosmic vacuums, but places where the curvature of space-time becomes infinite. They are locations where the fabric, under an immense weight, has stretched into a bottomless well. The event horizon is not a physical surface, but the point of no return around this well, the lip beyond which the slope becomes so steep that not even light can climb out. Within this region, the curvature is so extreme that the concepts of space and time themselves swap roles. The path inward becomes as inevitable as the flow of time forward. A black hole is less an object and more a permanent, silent knot in the fabric of the universe, a place where the geometry of reality becomes a one-way street. We do not know what, if anything, lies at the very center of a black hole, a place called a singularity. Our current laws of physics gently break down there. It may be a point of infinite density, or it may be a gateway to something beyond our current understanding. It is the ultimate unknown, a quiet question mark at the heart of Einstein's equations. What we can observe is the effect on the space around it. Stars can orbit an invisible point, their paths tracing out the presence of this profound curvature. The singularity itself is hidden, a secret kept safe by the extreme geometry of space-time, a reminder that our knowledge of the cosmos is still soft around the edges. The Earth does not simply orbit a sun that is sitting still. The sun too has mass, and it creates its own smaller dimple in space-time. As the planets orbit, they are not circling a static point, but a moving depression. The sun itself wobbles slightly, pulled by the gentle gravitational tugs of Jupiter and the other worlds. This means the entire solar system is a complex, interconnected landscape of gently rolling hills and valleys in space-time, all slowly shifting as the planets move. We are not just rolling in the sun's groove. We are all collectively gently shaping the fabric through which we travel in a slow, collaborative dance, the whisper of mass. The most precise measurements of gravity often happen not with vast telescopes, but in quiet, underground laboratories. Here, scientists use instruments called torsion balances to listen for the faintest gravitational whispers. These devices can measure the almost imperceptible attraction between lead spheres in a vacuum, a gentle pull so small it is dwarfed by the influence of a person simply walking past the room. This is the fundamental challenge of studying gravity. It is the weakest force, easily masked by every other interaction in the universe. To hear its quiet voice, we must create spaces of profound stillness, isolating the experiment from the vibrations of trucks on distant roads and the subtle currents of air, patiently waiting for the silent pull to reveal itself. We do not know why gravity is so astonishingly weak compared to the other forces. The electromagnetic force that holds atoms together is a trillion times stronger. This profound mystery is known as the hierarchy problem. One theory suggests that while other forces are confined to our three-dimensional space, gravity may be diluted because it can seep into extra, unseen dimensions of reality. It is a humbling thought, The force that binds galaxies may feel weak to us only because its true strength is spread thinly across a hidden cosmic landscape. The reason for this remains one of the most deep and quiet puzzles in all of modern physics, a gentle reminder of how much we have yet to understand. Every object you can see or imagine has a gravitational field, a personal whisper in space-time. This includes you. Your own mass exerts a gentle pull on the Earth, on the furniture in your room, and on the people near you. Of course, this pull is vanishingly small, overwhelmed by the planet's immense attraction. But it is there, a constant, quiet expression of your presence in the universe. This mutual attraction means that as you walk, you are ever so slightly shifting the ground beneath you. The atoms in your body are in a continuous, gentle dialogue with the atoms of the world around you. It is a connection so soft we never feel it, a fundamental belonging written into the law of the cosmos. The Cavendish experiment, performed in 1797, was the first to measure the gentle gravitational pull between human-made objects. Henry Cavendish used a torsion balance with lead spheres to observe how the small weights attracted each other. He famously called it weighing the Earth, as his measurement allowed him to calculate our planet's mass. This was a moment of quiet revolution. It demonstrated that the same force that guided the moon was also at work in a basement laboratory, acting on mundane spheres of metal. It wove the heavens and the Earth together with a single, gentle thread, proving that the cosmic dance was also happening here, on a miniature, human scale. Dark matter is perhaps the greatest testament to gravity's quiet voice. We cannot see it, touch it, or interact with it in any way except through gravity. We know it is there because galaxies rotate too quickly for the visible matter to hold them together. Their stars should fly apart, but something's unseen mass, its gentle gravitational whisper, provides the necessary glue. We do not know what dark matter is. It appears to be a vast, invisible scaffolding upon which the luminous universe is built. It does not shine or absorb light. It only bends space-time with its mass. It is the dominant architectural force in the cosmos, and yet, its fundamental nature remains one of the most profound and gentle mysteries. Some theories suggest that gravity may not be a fundamental force at all, but an emergent phenomenon. Just as the concept of temperature emerges from the chaotic jostling of countless molecules, gravity may emerge from the complex interactions of trillions of tiny, theoretical strings or quantum bits of information. In this view, space-time and its curvature are a collective illusion, a tapestry woven from simpler threads. This idea is still just a whisper itself, a theory on the farthest frontiers of physics. We do not know if it is true, but it invites a perspective where the force that gives us weight is not a primary actor, but a secondary effect, a gentle and large-scale consequence of a deeper, more hidden reality. Even on the smallest scales, gravity is present, though its voice is nearly silent. Two specks of dust floating near each other in the vacuum of space will, over eons, drift together due to their mutual gravitational attraction. It is a process of unimaginable patience, a slow motion coming together that requires no other force, just the unwavering, gentle pull of mass. This illustrates that gravity is universal and unceasing. It works across all scales of size and time, from the slow assembly of dust clouds into planets to the grand clustering of galaxies. There is no minimum mass required to participate in this cosmic attraction. It is a right granted simply by existing, a quiet invitation to connect. The birth of pull-in. The beginning, after the universe burst into being, it was a nearly smooth soup of hydrogen and helium, expanding rapidly. There were no stars, no galaxies, only a faint, gentle unevenness, a whisper of density. In these slightly denser patches, gravity found its first foothold. Over hundreds of millions of years, this faint whisper began to pull, gathering atoms together in the vast, dark silence. This was the first creative act of gravity, a patient gathering that would eventually build everything we see. It did not rush. It worked with the slow, persistent patience of a force that knows it has all of time at its disposal. From imperceptible ripples, it began to weave the first structures, drawing threads of gas together to write the first chapter of the cosmic story. A nebula is a cosmic nursery, a vast and drifting cloud of gas and dust. For eons, it may simply exist, a silent and diffuse structure. But then, perhaps nudged by the shockwave from a distant supernova, a small pocket within it begins to coalesce. Gravity seizes this opportunity, amplifying the slight collapse, pulling more and more material inward toward a common center. As this core grows denser, the pressure and heat at its heart begin to rise. For millions of years, the cloud contracts a slow and gentle deflation. Eventually, the temperature and pressure reach a critical point, and nuclear fusion quietly ignites. A star is born, its light a testament to gravity's patient, gathering power. We do not know precisely why galaxies take the specific shapes they do, spiral, elliptical, or irregular. But we know gravity is the sculptor. In the early universe, vast halos of dark matter acted as invisible gravitational scaffolds. Ordinary matter, the gas and dust that would become stars, was drawn into these halos, settling into vast, spinning disks all round, swelling clouds. The beautiful arms of a spiral galaxy are not static structures, but density waves like a cosmic traffic jam slowly circling the galactic core. They are shaped and maintained by gravity's gentle shepherding, a rhythmic pattern in the flow of stars and gas, a slow-motion whirlpool of billions of suns. Before the first stars flickered on, the universe was in a period known as the Cosmic Dark Ages. There was no light to see by. The only actor on the stage was gravity, slowly, quietly pulling the first structures together in the profound dark. This era lasted for hundreds of millions of years, a long, quiet gestation before the dawn of the first luminous objects. During this time, the universe was peacefully silent and dark, its future written only in the gentle, inexorable collapse of gas under its own weight. The birth of the first stars was the end of this long night, a gentle sunrise that began to illuminate the architecture gravity had been patiently building all that time. Our own solar system began not as a finished blueprint, but as a ragged disk of gas and dust orbiting the infant sun, a proto-planetary disk. Within this disk, microscopic dust grains gently collided and stuck together, a process called accretion. As these clumps grew larger, their gravitational pull grew stronger, allowing them to gather material more quickly. Over a few million years, these planetesimals swept their orbits clear, colliding and merging to form the planets we know today. Jupiter likely formed first, its strong gravity shaping the rest of the system. This was a gentle, chaotic construction project, where gravity acted as the foreman, guiding random collisions into an ordered, stable family of worlds. The habitable zone, the region around a star where water can exist as a liquid, is a gift of gravity's precise balance. It is the distance at which the star's gravity holds a planet in a stable orbit, while also allowing the right amount of stellar energy to reach the surface. Too close and the world is scorched. Too far and it is frozen. Gravity created the conditions for this delicate balance by forming the star and orchestrating the planetary dance around it. Our Earth found itself in this gentle golden lane, a perfect orbital distance that allowed for the slow, patient evolution of life, all governed by the quiet laws of attraction. Gravity is a force of gentle filtration in the cosmos. In a forming solar system, lighter elements and gases like hydrogen and helium are more easily lost to space, especially from smaller worlds. Heavier elements like iron and silicon are more readily held by a planet's gravitational grasp. This is why small Mercury has a thin mantle of rock over a large iron core, while massive Jupiter could hold on to the vast, light atmosphere that defines it. This sorting mechanism, acting over billions of years, creates the diversity of worlds we observe. A planet's final composition is, in many ways, a record of its gravitational strength during formation, a testament to how strongly it could hold on to the building blocks swirling around its infant star. The long letting go, for all its power to build and gather, gravity also presides over a slow, cosmic release. The universe is expanding, and on the larger scales, this expansion is gradually accelerating, driven by a gentle, mysterious force we call dark energy. Over trillions of years, this means distant galaxies will be carried away from one another, their gravitational bonds stretched and finally broken. This is not a violent rupture, but a quiet fading. The light from those galaxies will redshift into invisibility, and the observable universe will slowly shrink to include only our nearest galactic neighbors. It is a long, slow letting go, a gentle dissolution of the grand structures that gravity once so patiently built. Even within bound systems, there is a gentle loss. When two galaxies merge, their dance is not perfectly efficient. Gravity's complex interactions can fling stars out into the intergalactic void. These are called rogue stars, solitary wanderers set adrift from their galactic homes. They will travel alone through the cold, dark space between galaxies, their light fading over eons. This is a form of cosmic evaporation, a slow leakage of matter from gravitational wells. It happens gradually over billions of years, as gravity itself rearranges its own creations, sometimes casting a small fraction of them back into the emptiness from which they came. The Earth itself is in a state of gradual release. Our moon is slowly drifting away from us at a rate of about 4 centimeters per year. This is a result of tidal interactions where gravity transfers rotational energy from the Earth to the moon, gently pushing its orbit further out. The Earth's spin is imperceptibly slowing, and the moon is patiently receding. This is a separation measured in billions of years. The process is so slow, so gentle, that it is undetectable in a human lifetime. It is the quiet unwinding of a cosmic dance, a long and patient farewell between two partners who have been together since the solar system's violent youth. All stars eventually exhaust their nuclear fuel. When a star like our Sun dies, it will swell into a red giant and then gently expel its outer layers into space, forming a beautiful planetary nebula. The remaining core, a white dwarf, is an Earth-sized ember of incredible density. It has no fuel left to burn, and it will simply cool, fading over trillions of years into a cold, black dwarf. This is the ultimate fate of most stars. Not an explosion, but a quiet dimming. Gravity holds the white dwarf together, but there is no longer any energy to resist its slow, relentless crush. The star becomes a dark, silent monument to gravity's patient, final victory over light and heat. On a cosmic timescale, even orbits are not forever. They slowly decay. This is due to gravitational radiation, the gentle ripples in space-time that orbiting masses produce. These waves carry away a tiny, almost imperceptible amount of energy, causing the orbiting bodies to spiral inward ever so slowly. For the Earth and Sun, this process would take far longer than the current age of the universe. It is a reminder that no motion is perfectly perpetual. Every dance, no matter how stable, is gradually losing its energy, its steps becoming subtly smaller over aeons. It is the universe's slow and gentle winding down, a whisper of entropy in the gravitational field. We do not know the ultimate fate of matter in the farthest future. One hypothesis suggests that even the protons and neutrons that make up atoms may not be permanent. Over timescales so vast they defy imagination, this matter may slowly decay into energy. If this is true, then even the black dwarfs and planets will eventually dissipate, leaving behind only a diffuse sea of particles and radiation. In this distant era, gravity's work of construction would be entirely complete, followed by an epoch of the slowest possible dissolution. The universe would be a quiet, dark, and increasingly empty place, a gentle conclusion to the long story of structure and form. The concept of heat death represents the final equilibrium, a state where energy is evenly distributed throughout the cosmos and no more work can be done. In this distant future, gravity may still be at work, but its tasks will be subtle. It may very slowly gather the last remaining particles into vast, diffuse clouds over trillions upon trillions of years, but eventually, even this gentle gathering may be overcome by the relentless expansion of space. The universe would then become a truly static, cold, and dark expanse. It is not an end of existence, but an end of change, a final, deep and quiet rest presided over by the same force that once gave it birth. The unseen ocean. The universe is filled with an unseen ocean, not of water, but of space-time itself. And just as a stone dropped into a pond creates ripples, massive accelerating objects create ripples in this fabric. These are gravitational waves traveling outward at the speed of light, stretching and squeezing everything in their path in a silent, rhythmic dance. We do not know all the cosmic events that create these gentle ripples, but the most powerful come from the most violent ballets, black holes and neutron stars merging. These waves are not made of matter, but of pure geometry, a traveling distortion in the very shape of reality. They are the quietest whispers of the cosmos, carrying stories of events that happened billions of years ago. When a gravitational wave passes through you, it does so completely unnoticed. It gently stretches your body in one direction, while simultaneously squeezing it in the perpendicular direction. This distortion is incredibly tiny, far smaller than the width of a single proton. You are constantly being reshaped by these cosmic ripples, a participant in a silent symphony you can never feel. This is because gravity is so weak. The waves it produces are the faintest of all signals in the universe. To detect them requires not just incredible technology, but a profound patience, an ability to listen for a whisper in a cosmic hurricane of noise, to feel a vibration softer than any other in existence. The LIGO observatories are perhaps the most silent listening posts ever built. Their two immense arms, each 4 kilometers long, are kept in a vacuum more empty than the space between planets. A powerful laser beam is split and sent down each arm, bouncing between mirrors. A passing gravitational wave will ever so slightly change the length of one arm relative to the other, creating a tiny shift in the laser light. The detection of these waves in 2015 was not a loud announcement, but a quiet confirmation of a century-old prediction. It was the moment we learned to listen to the universe in a new way, not with light or radio waves, but with the gentle vibrations of space-time itself, hearing the cosmos with a new, profound sense. The first gravitational waves ever detected told a story of a final, graceful embrace. They were produced over 1 billion years ago when two black holes, locked in a mutual orbit, slowly spiraled closer and closer together. In their final moments, they circled each other hundreds of times per second, ringing space-time like a final, quiet chime before merging into a single, more massive black hole. The energy released in that final merger was staggering, but its expression in our detectors was a gentle, rising chirp that lasted less than a second. It was the sound of a cosmic birth, a new black hole settling into the universe, its story told not with light, but with a subtle tremor in the dark. Neutron star mergers also send out powerful ripples, but they come with a light show. These incredibly dense, city-sized objects are the remnants of supernova explosions. When they spiral together and collide, they do not vanish into an event horizon immediately. Instead, they forge heavy elements like gold, platinum, and uranium in a brilliant kilonova explosion. This means a gravitational wave signal can be accompanied by a flash of light across the electromagnetic spectrum. It is a multi-messenger event where we both feel the ripple in space-time and see the glittering, precious debris it leaves behind, a beautiful collaboration between the seen and the unseen forces of the cosmos. The universe is not silent, but filled with a background hum of gravitational waves. This is the combined signal from countless merging supermassive black holes throughout cosmic history, a choir of low-frequency ripples that constantly wash over our galaxy. We have not yet directly detected this hum, but pulsar timing arrays are slowly listening for it, using the precise flashes of dead stars as a galactic-scale metronome. This background is the quiet, collective memory of the universe's most massive mergers. It is the softest of all symphonies, a testament to the fact that even in the seeming void of space, there is a gentle, ongoing vibration, a residual tremor from the construction of the cosmic web itself. As two black holes in spiral and merge, the resulting single black hole does not sit silently. It rings like a quiet bell. The new, asymmetrical shape oscillates, sending out its own set of gravitational waves as it settles into a perfect, featureless sphere. These are called the ring-down waves, the final fading notes of the collision. This gentle ringing allows us to measure the new black hole's mass and spin to understand its fundamental properties. It is a cosmic fingerprint etched not in ink, but in the fleeting distortions of space-time, a quiet signature that slowly fades into the background hum of the universe, a final whisper from a moment of immense transformation. The anchor of life. The gentle pull you feel toward the Earth is not just a force. It is an anchor that shaped life itself. From the earliest single-celled organisms that drifted in ancient seas, gravity provided a constant downward reference. It told plants which way to send their roots, digging into the soil for water and minerals, and which way to send their shoots, reaching for the sun. This unceasing, gentle pressure became the silent director of growth and form. Without this consistent pull, the very architecture of life would be different. There would be no tall trees, for their wooden skeletons evolved to resist gravity's constant persuasion. There would be no upright walking, for our skeletons are a delicate balance of levers and pulleys, all calibrated for this one specific force. Gravity is the quiet, unseen sculptor of the living world. Your body is a continuous conversation with gravity. Your bones are not solid. They are living, dynamic structures that constantly remodel themselves in response to the mechanical stress of bearing weight. In the profound quiet of space, astronauts lose bone density at a rate of about 1% per month, as their bodies, no longer feeling the familiar pull, gently begin to shed what it perceives as unnecessary scaffolding. This is a process called osteoporosis, happening slowly in the absence of our gravitational anchor. It reveals that our strength is not a fixed possession, but a gentle negotiation with the force that holds us to the ground. Our bodies are built moment by moment in a silent dialogue with the planet. The very flow of fluids within your body is guided by gravity's gentle hand. Your circulatory system, with its heart as a pump, is designed to work against this constant downward pull, pushing blood upward to your brain. When you stand up too quickly, you might feel a brief dizziness, a momentary lag as your body adjusts the pressure, a quiet reminder of the force it is always working to overcome. Meanwhile, the subtle drainage of fluids from your tissues, a process that prevents swelling, relies on gravity's gentle assistance. As you lie down to sleep, this flow shifts, a quiet internal reorientation that is part of the body's nightly reset, all orchestrated by our constant planetary anchor. We do not know if life could have evolved on a world with significantly different gravity, but we can observe how life here has adapted to its gentle, unyielding presence. The tallest land animals, like giraffes, have immensely powerful hearts and specialized vascular valves to pump blood up their long necks. The blue whale, buoyed by the ocean, can grow to such immense size precisely because water supports its weight, freeing it from gravity's crushing limitations on land. This suggests that gravity sets the boundaries for biological design. It dictates the maximum height of a tree, the possible size of a land animal, and the structural strength required for flight. It is the silent, environmental parameter that has quietly guided every evolutionary innovation. Your sense of balance is a gift of gravity. Deep within your inner ear, the vestibular system contains tiny crystals of calcium carbonate called otoliths, resting on a bed of sensitive hairs. When you tilt your head, gravity pulls these tiny stones, bending the hairs and sending a signal to your brain about your orientation in space. It is a biological spirit level, a quiet, internal instrument calibrated by the Earth's steady pull. This system allows you to walk without conscious thought, to know up from down, even with your eyes closed. It is a fundamental, often unnoticed sense, a constant, gentle feedback loop between your body and the planet, creating the stable world you perceive. This system allows you to walk without conscious thought, to know up from down even with your eyes closed. It is a fundamental, often unnoticed sense, a constant, gentle feedback loop between your body and the planet, creating the stable world you perceive. The gentle pressure of gravity may have been a quiet catalyst for life's very beginning. In the early oceans, tidal pools created by the moon's gravitational pull would have provided a dynamic environment. The slow cycle of filling and emptying, of concentration and dilution, of warming and cooling, could have gently encouraged the complex chemical reactions that led to self-replicating molecules. In this view, gravity provided not just a stage, but a gentle, rhythmic stirring of the primordial soup. The moon patient tug, creating the tides, may have been a quiet midwife to life, a slow and persistent motion that helped nudge chemistry toward biology in the warm, shallow edges of a young world. As you drift to sleep, gravity's role shifts from an active force to a comforting presence. The pressure of your mattress against your body is a gentle reminder of its hold. The weight of your blankets provides a soft, reassuring pressure. In the micro movements of the night as you turn over, your body subconsciously seeks a new equilibrium, a comfortable alignment within this constant field. This is gravity as a gentle guardian of your rest. It holds you securely to the earth, a fundamental safety that allows your body to fully surrender to sleep. It is the silent, constant embrace that lets you know you are home, anchored safely to the world, free to dream among the stars. From quarks to clusters on the smallest scales imaginable, gravity is a whisper that is almost completely drowned out. Between two quarks dancing within a proton, the strong nuclear force is over 1,000,000 trillion times more powerful. Gravity is so faint here that its influence is essentially zero, a silent spectator to the vibrant, binding energy that builds the atomic nucleus. It is a force that belongs to the world of the very large, leaving the tiny quantum realm to its own, more vigorous laws. We do not know if gravity has a quantum form of its own, a hypothetical particle called a graviton. The theory suggests that these massless particles would gently carry the gravitational force, but their interaction would be so weak, so subtle, that detecting a single one may be forever beyond our reach. On this minute scale, gravity remains a beautiful, quiet mystery. As we move from quarks to atoms, gravity's voice remains a quiet murmur. The electromagnetic forces that bind electrons to their nuclei are still astronomically stronger. The gravitational attraction between two neighboring atoms is utterly insignificant compared to the chemical bonds they can form. This is why a small magnet can lift a paperclip, effortlessly defeating the collective gravitational pull of an entire planet on the clip's atoms. This incredible weakness is what allows complex chemistry to exist. If gravity were even slightly stronger at this scale, it would overwhelm the delicate balances of atomic and molecular forces, and the diverse structures of matter, from a water molecule to a strand of DNA, might never have quietly formed. With a small handheld object like an apple, gravity finally begins to make its gentle presence known. Here, the collective mass of trillions upon trillions of atoms sums together, creating a pull that we can feel in our hands as weight. The apple's fall is the result of every one of its particles being attracted to every one of the Earth's particles, a symphony of tiny attractions culminating in a single, gentle descent. This is the scale of human experience, where gravity transitions from an invisible theoretical force to a tangible daily reality. It is the scale of dropped keys and resting books, where its patient pull becomes the quiet organizer of our physical world. On the planetary scale, gravity reveals its true nature as a cosmic architect. It is the force that patiently gathered dust and gas into spheres, pulling until the material could pull no closer. It holds atmospheres in place, a gentle blanket of gas wrapped around a world. It sculpts mountains, then slowly, over eons, wears them down again, in a perpetual, gentle negotiation between uplift and erosion. A planet's gravity defines its very character. Strong gravity creates a thick, crushing atmosphere like Venus's. Weak gravity, like that of Mars, allows its air to slowly leak away into space. It is the silent author of a world's environment, writing the rules for its weather, its oceans, and its potential for life. The scale of a star is where gravity achieves a magnificent, fiery balance. For millions or billions of years, the immense inward crush of a star's own weight is perfectly countered by the outward pressure from nuclear fusion in its core. This equilibrium is a slow, stable burn, a gentle standoff that creates the steady light that nurtures planets. The star is a controlled explosion, held together by gravity's patient, unyielding embrace. When the star's fuel is depleted, this balance is broken. Gravity, which has been held at bay for so long, finally wins its long game. The star's fate, whether it becomes a white dwarf, a neutron star, or a black hole, is determined solely by the final, gentle victory of its own mass over the forces that resisted it. At the galactic level, gravity weaves hundreds of billions of stars into a single, coherent structure. It is the thread that stitches them into vast spirals, elegant ellipses, or ragged, irregular shapes. But here a mystery deepens. The visible stars and gas do not provide enough gravity to hold these fast-spinning galaxies together. This is the quiet evidence for dark matter, an unseen form of mass whose gravitational whisper provides the extra glue. A galaxy, then, is a dual entity, a luminous heart of stars and gas, embedded within a much larger invisible halo of dark matter. It is gravity's most grand and mysterious tapestry, woven from both the seen and the profoundly unseen. On the very largest scales, gravity constructs the cosmos itself. It draws galaxies together into clusters and clusters into long, winding filaments that form a cosmic web, with vast, empty voids between them. This is the large-scale structure of the universe, a pattern that traces the gentle hills and valleys of gravity's potential that were seeded in the first moments of the Big Bang. This web is the ultimate expression of gravitational gathering. It is a structure so immense that it takes hundreds of millions of years for light to cross its threads. And within this web, every galaxy, every star, every planet, and every one of us is simply following the gentle, curved paths that gravity laid down at the dawn of time. The pulse of orbits. The solar system moves to a quiet, rhythmic music. Johannes Kepler discovered that a planet's orbital period is mathematically tied to its distance from the Sun. A world twice as far from the Sun as another does not take twice as long to orbit, but closer to 3 times as long. This is his third law, a harmonic rule that governs the pace of every planet's journey, from the swift year of Mercury to the slow, majestic orbit of Neptune. This relationship is not a coincidence, but a direct consequence of gravity's gentle weakening with distance. It means the solar system is not a random scattering of worlds, but an ordered system, a clockwork of immense scale where each gear turns in a precise, predictable rhythm, a slow and patient celestial metronome. Some orbits fall into a gentle, repeating rhythm with one another, a phenomenon known as orbital resonance. Jupiter's moons, Io, Europa, and Ganymede are locked in a perfect 1-2-4 resonance. For every single orbit Ganymede completes, Europa completes 2, and Io completes 4. This regular gravitational tugging keeps their orbit stable and predictable, a celestial waltz that has continued for billions of years. These resonances are like the harmonious chords in the solar system's music. They prevent the orbits from becoming chaotic, gently nudging the moons back into their rhythmic patterns whenever they begin to drift. It is a self-correcting dance, a quiet agreement written in the language of gravity and motion. We do not know exactly how the first planetary orbits were set into their resonant rhythms. It is likely they migrated slowly through the protoplanetary disk, gently pushing and pulling on each other with their gravity until they settled into these stable, harmonious configurations. It was a slow, patient process of finding a mutual balance, like pendulums on a shared beam eventually falling into sync. This means the orderly orbits we see today are the end result of a long, quiet tuning process. The solar system found its most stable, most peaceful state and has been quietly maintaining that harmony ever since, a testament to gravity's role as a cosmic peacemaker, gently organizing chaos into long-term rhythm. The asteroid belt is not a chaotic jumble of rocks, but a region sculpted by rhythm. Vast, empty bands known as Kirkwood gaps exist within it, where the orbital period of any asteroid would be a simple fraction of Jupiter's. An asteroid in such an orbit would feel Jupiter's gravitational tug at the same point in its path, over and over again, like a child being pushed on a swing in perfect time. This repeated rhythmic nudging would eventually perturb the asteroid's path, gently ejecting it from that resonant orbit. The gaps are therefore silent testimony to Jupiter's influence, a record of orbits that were too rhythmic to survive, cleared by the steady, patient pulse of the giant planet's gravity. Binary stars are the most direct expression of orbital rhythm. 2 stars, bound by gravity, slowly revolve around a common center of mass. Some take days to complete their dance, while others take centuries. From a planet within such a system, there would be 2 suns tracing slow, predictable arcs across the sky, their light rising and setting in a complex yet perfectly regular ballet of shadows and illumination. The rhythm of their orbit determines the stability of any planetary system around them. A planet must orbit at a respectful distance, or the gentle, rhythmic tugs from 2 stars instead of 1 would slowly pull its path apart. It is a delicate balance, a dance within a dance, all governed by the same silent pulse. Even our own planet has a subtle rhythmic pulse in its orbit, known as the Milankovitch cycles. Over hundreds of thousands of years, the Earth's orbit slowly stretches and contracts, its axial tilt gently wobbles, and its axis slowly precesses, like a spinning top winding down. These are not changes we can feel, but they are the quiet, rhythmic heartbeat of our climate, gently influencing the coming and going of ice ages over deep time. This is the grandest rhythm of all, a pulse measured in epochs. It reminds us that our stable world is part of a much longer, slower story, a story of gentle orbital variations that have quietly shaped the history of life itself. At the very edge of our solar system in the Kuiper belt, there are clusters of objects that share similar, highly elongated orbits. This configuration suggests the gentle, rhythmic influence of a distant, yet undiscovered planet. The hypothetical Planet 9, if it exists, would be shepherding these smaller worlds, its slow, multi-thousand-year orbit creating a resonant pattern that gathers them into a harmonious, if distant, choir. This is a rhythm we are still learning to hear, a faint, slow beat on the very frontier of our gravitational awareness. It is a quiet reminder that the music of our solar system may have more movements than we currently know, with a conductor whose presence we have only just begun to suspect. The silent messengers in the quantum realm, forces are carried by tiny messengers, particles that gently ferry influence between matter. For the electromagnetic force, the messenger is the photon, a massless particle of light that creates the push and pull between charged particles. Every beam of light, every radio wave is a stream of these silent messengers communicating the force across empty space. We do not know if gravity has such a messenger for certain, but physicists propose the graviton. This hypothetical particle would be massless and chargeless, a gentle whisper of a particle that would carry the gravitational force. Unlike the robust photon, the graviton would interact with matter so weakly that its detection remains a dream of far future science. If gravitons exist, they would be the most solitary of messengers. A photon can be easily absorbed or reflected by an electron, creating the world of sight and color we experience. But a graviton, theorized to be incredibly elusive, would pass through almost any matter completely undisturbed. Trillions of them would be passing through your body every second, their gentle influence too faint to be noticed amidst the roar of other forces. This is why gravity is so weak and yet so pervasive. Its proposed messenger does not confront or collide, it simply permeates, a silent courier delivering its message of curvature through everything, from the densest star to the most empty void, without ever stopping to interact. Light, carried by its photon messengers, is itself bent by gravity. This creates a beautiful paradox. The messenger of one force becomes a tracer, revealing the presence of another. When starlight curves around a massive galaxy, it is the photons that are following the curved path dictated by gravity. We see the effect, but we do not see the gravitons that may have created the curvature. This interplay is a quiet dialogue between forces. We use the visible, tangible photons to map the invisible, ethereal influence of gravity. One set of messengers illuminates the path, while the other set, unseen, is responsible for the path's very shape. The concept of a force carrier helps explain the strange nature of action at a distance. The sun does not simply pull on the Earth mysteriously. In the quantum view, the space between them is filled with a quiet exchange of virtual gravitons. These are temporary, fleeting particles that pop in and out of existence, creating the net effect of the gravitational pull that holds our world in its steady orbit. It is a gentle, continuous conversation. The Earth is constantly emitting its own virtual gravitons toward the Sun and receiving the Sun's in return. This silent subatomic traffic is what we experience as the stable, patient force of gravity, a relationship built on countless tiny, unseen handshakes. We do not know how to reconcile the gentle, geometric curvature of Einstein's gravity with the frantic quantum world of particles. This is the great challenge of a theory of quantum gravity. In the quantum realm, empty space is not smooth, but a seething foam of virtual particles. How does this foam curve? How does the smooth fabric of space-time emerge from such chaos? This remains one of the deepest mysteries in physics. The graviton is a proposed bridge between these two worlds, a particle that would hopefully explain how the large-scale architecture of the cosmos is built from the smallest possible pieces. For now, the bridge remains unfinished, a beautiful, ethereal idea. In the intense heat of the early universe, all forces were likely unified. Photons, gravitons, and the messengers of the nuclear forces may have been indistinguishable. As the cosmos expanded and cooled, these forces gently separated, or froze, out, each gaining its own identity and its own unique messenger. The graviton was the first to part ways, its incredible weakness setting it apart from the very beginning. This means the history of the universe is a story of forces slowly finding their own roles. The graviton, if it exists, carries the memory of that first unified state, a silent relic from a time when all of physics was one. Whether as a wave in space-time or a stream of gravitons, gravity's message is one of connection. It is the universe's way of ensuring that no particle is ever truly isolated. Every bit of mass, from a quark to a quasar, is in a gentle, continuous dialogue with every other bit of mass through the softest and most persistent force. As you rest, these silent messengers, real or hypothetical, are passing through you. They are the threads that tie you to the moon, to the sun, to the distant stars. You are not alone in the universe. You are in constant, quiet conversation with it through the most ethereal of messengers and the most gentle of touches. The ancient curvature, in the very first moments of the universe, gravity was already present, a quiet potential waiting in the nascent fireball. As the cosmos expanded and cooled from a state of unimaginable density, gravity began its patient work. It was the first force to separate from the others, its unique character of pure attraction setting it apart, a gentle architect stepping forward to begin the long task of building structure in the void. We do not know the precise nature of gravity in that first singular instant. The conditions were so extreme that our current laws of physics gently break down, leaving the moment of Genesis wrapped in a soft, theoretical haze. But we know that shortly thereafter gravity was there, the oldest and most persistent force, ready to shape everything to come. For the first 380,000 years, the universe was a dense, opaque fog of plasma, where light was constantly scattered by free electrons. During this time, gravity worked silently in the dark. Tiny quantum fluctuations, magnified by a period of rapid inflation, created minute variations in density. In these slightly denser patches, gravity found its foothold, beginning to gently pull matter together, even as the radiant pressure of light pushed it apart. This was the cosmic dark ages in its truest form. The universe was a silent, dark sea, with gravity as the only sculptor, slowly gathering the material for the first stars and galaxies. It was a patient, invisible preparation for the dawn of light. The release of the cosmic microwave background was a moment of quiet liberation for light. As the universe cooled enough for atoms to form, the fog cleared and photons began their long journey across the cosmos. But etched into this first light is the faint blueprint of gravity, slightly warmer and cooler, spots that correspond to the density, variations gravity was already working on. This ancient light is a snapshot of the universe's infancy, and it reveals the seeds of all future structure. The gentle hills and valleys in this radiation are the primordial curvature that gravity would spend the next 13.8 billion years patiently amplifying into the cosmic web we see today. As the Dark Ages ended, gravity's patient gathering culminated in the birth of the first stars. These population 3 stars were likely immense, burning hot and fast, and their formation was a quiet revolution. Their ignition flooded the universe with its first new light since the Big Bang, slowly burning away the primordial hydrogen fog in a process called Ryanization. This was the end of the universe's dark, formless era. Gravity had built the first luminous beacons, and in their brilliant short lives they forged the first heavy elements, seeding the cosmos with the material for future planets, and, eventually, for life. With the first stars came the first black holes, and with them, the first large-scale curvature of spacetime. These ancient gravitational pits formed from the collapse of massive stars began to anchor the first proto-galaxies. Their immense pull gathered vast clouds of gas and the first generations of stars, serving as the silent, dark hearts around which galaxies would slowly assemble and spin. This was the beginning of gravity's grandest architecture. The black holes did not just consume, they organized. Their profound curvature acted as a gravitational keystone, providing a stable center for the chaotic process of galaxy formation. A role many continue to play today. Over billions of years, gravity orchestrated the slow dance of galaxy formation and merger. Small proto-galaxies, drawn together by their mutual attraction, gently collided and merged, building larger and larger structures. Our own Milky Way is a product of this ancient, patient construction, a tapestry woven from the threads of smaller galaxies consumed long ago, their stars now quietly integrated into the great spiral. This process continues even now. The Milky Way and its neighbor, the Andromeda Galaxy, are slowly, inevitably drifting toward one another, drawn by the same ancient curvature. In billions of years, they will merge in a slow, stately dance, a future event written by gravity's patient, persistent hand. The story of gravity is the story of the universe itself. From a featureless fireball, it patiently drew forth stars, galaxies, and worlds. It is the thread of connection that has woven the cosmos into a coherent whole. The same gentle force that caused the first gas clouds to coalesce now holds your feet to the ground in an unbroken chain of cause and effect, stretching back to the very beginning. The ancient curvature set in motion at the dawn of time is still shaping reality today. It is the memory of the universe, a persistent, quiet influence that has guided the evolution of all structure, from the largest galaxy cluster to the orbit of a single, sleeping world. The future of drift in the far, far future, the universe will continue its long, slow expansion. The gentle force of dark energy appears to be a constant, patiently pushing galaxies apart. Over trillions of years, all galaxies outside our own local group will drift beyond our cosmic horizon, their light stretched into invisibility. The night sky, which now teems with faint, distant islands of stars, will grow quiet and dark, leaving only the few galaxies bound to us by gravity as lonely companions in an immense black void. This is not a violent separation, but a quiet fading. It is the gradual dissolution of the grand cosmic web that gravity spent billions of years building. The universe will become a collection of isolated galactic neighborhoods, each drifting alone in their own pocket of space, their shared history slowly forgotten. Within our own galaxy, the long dance of stars will continue, but it too will slowly change. Over immense timescales, the gentle gravitational interactions between stars will act like a slow-motion game of billiards. Some stars will be nudged into new orbits, while others will be gently ejected from the galaxy entirely, becoming solitary wanderers in the intergalactic dark. The galaxy's structure will very slowly, very softly, begin to evaporate. This process, known as dynamical relaxation, is a testament to gravity's patience. It works not with sudden force, but with countless gentle nudges over aeons, gradually rewriting the star map of the galaxy in a script that takes longer than the current age of the universe to complete. All stars eventually will burn out. The last red dwarfs, those faint, frugal stars that can shine for trillions of years will finally consume their fuel. They will cool into black dwarfs, cold, dark spheres of degenerate matter, their faint heat radiated away into the cooling cosmos. The era of starlight will gently come to a close, and the universe will enter a long, dark age. Gravity will still be there, holding these stellar remnants in their silent orbits. But the universe will be a much darker place, illuminated only by the rare, soft glow of accretion disks around black holes or the fleeting flash of the last. In frequent collisions between brown dwarfs, we do not know the ultimate fate of matter itself. Some theories suggest that even the protons that form the cores of atoms are not perfectly stable. Over timescales so vast they defy comprehension, perhaps 10 to 34 years or more, protons may slowly decay into lighter particles and energy. If this is true, then even the cold, dead remnants of stars and planets will slowly, quietly dissipate into a thin haze of radiation and subatomic particles. In this distant era, gravity's work of construction would be completely undone. The complex structures of planets, white dwarfs, and neutron stars would gently vanish, leaving behind only a diffuse, ever-cooling sea of leptons and photons and the silent, patient black holes. Black holes are not eternal. Through a subtle quantum process at their event horizons, they slowly lose mass, emitting a faint whisper of radiation known as Hawking radiation. For a stellar mass black hole, this evaporation is an incredibly slow process, taking longer than the current age of the universe. But given enough time, they too will gently dissipate. Their mass energy returned to the cosmos in a final, quiet puff of radiation. The largest supermassive black holes will be the last structures to endure, holding on to their mass for perhaps 100 years. But eventually even these titans will fade away. Their evaporation marks the final end of all gravitational structures, a gentle goodbye from the last anchors of the ancient cosmos. In the very farthest future, the universe may approach a state of final equilibrium, known as the heat death. Energy will be uniformly distributed, and no more work can be done. The temperature will approach absolute zero. In this vast, dark and cold expanse, the universe will be a static, featureless void. The great story of structure, from galaxies to atoms, will have reached its quiet final page. Gravity will still exist, but its work will be complete. There will be no more hills to roll down, no more structures to build. It will be a force without a task, a silent, constant presence in a universe that has achieved a final, deep, and eternal rest. The universal embrace. From the whisper between quarks to the silent grip of a black hole, gravity is a single, continuous story. It is the gentle thread that weaves through every scale of reality, from the quantum foam to the cosmic web. The same principle that causes an apple to fall also guides the stately dance of galaxies, a universal language of attraction spoken in the quiet geometry of spacetime. It is not many forces, but one with a single, patient purpose: to connect. This unifying embrace means you are not separate from the cosmos you observe. The force you feel as you lie in your bed is the very same force that holds the moon in orbit and binds the Milky Way together. There is no boundary where one gravity ends and another begins. It is a single, pervasive field, a universal condition in which we all exist and move. We have wandered from the gentle curvature that tells a planet how to orbit, to the ripples that carry news of cosmic collisions. We have seen how gravity is both the architect of stars and the anchor for life. It is the sculptor of the large-scale structure of the universe, and the quiet hand that guides the fluid in a plant's stem. Its roles are diverse, yet its nature is singular, a persistent, patient drawing together. It is a force that works as willingly with dark matter as it does with light. It does not discriminate. Any form of energy or mass, seen or unseen, participates in this gentle dialogue. Gravity is the great democratizer of the cosmos, acknowledging everything that exists and weaving it all into a single, interactive whole. The story of gravity is a narrative of deep time. It began its work in the first moments of the universe, patiently amplifying the faintest of whispers into the grandest of structures. It will continue its work for trillions upon trillions of years, presiding over the long, slow fading of starlight and the final evaporation of the last black holes. Its timeline is the timeline of the cosmos itself. In this vast expanse, our moment is a brief, warm flicker. But within that flicker, we have been granted the quiet awareness to perceive this force, to feel its gentle pull, and to trace its influence from our own bodies to the edge of the observable universe. It is a humbling and connecting thought. We do not know why the universe chose this particular force, with its specific weakness and its geometric nature, to be its principle of connection. The reason remains one of the deepest mysteries, but its existence has made our reality possible. A stronger gravity would have collapsed the universe too quickly. A weaker one would have left it a formless, expanding mist. Its precise value feels, in many ways, like a gentle invitation for structure and for life to emerge. This apparent fine-tuning is a quiet wonder. It suggests that our ability to ponder gravity is itself a product of gravity's specific, gentle character. We are not just observers of this force. We are, in a very real sense, one of its most intricate and delicate expressions. As you rest, remember that you are both a source and a subject of this universal embrace. The atoms of your body create their own tiny, gentle curvature in space-time. You are pulling ever so softly on everything around you, and everything is pulling on you. You are not a passive occupant of space, but an active participant in its geometry, a minor but real note in the cosmic symphony of attraction. This is the most personal synthesis. You are in a constant, silent, and reciprocal relationship with the entire cosmos. The distance between you and the stars is not empty. It is filled with the quiet, ongoing conversation of gravity, a connection that requires no effort, only your simple presence. So as we near the end of our journey, let the separate facts begin to blur and soften in your mind. Let the concepts of waves, curvature, orbits, and mass gently merge back into a single, cohesive whole. There is no need to hold on to the individual threads. The tapestry itself is what matters, the beautiful, interconnected reality where everything is in a state of slow, graceful fall toward everything else. A universal and endless embrace. There is a profound peace in this understanding. It means that to simply be, to rest, and to let go is to be in perfect harmony with the most fundamental force in the universe. You are not falling asleep in a world governed by gravity. You are surrendering to its most gentle and natural state. And now the stars begin to dim behind your thoughts. The gentle concepts we have wandered through start to soften and drift, like embers rising on a warm, quiet breeze. We have drifted through nearly 150 quiet truths about gravity, from the gentle architect of space-time to the silent messengers that may weave it all together. You have wandered from the quantum whisper to the cosmic embrace, gazed toward the birth of stars and the farthest future of drift. You have felt the anchor in your own body and the rhythmic pulse of distant orbit. And in this quiet understanding, remember this: you are part of this gentle pull, not just as a subject of its force, but as a participant. The atoms in your body were forged in the heart of ancient stars, gathered by gravity's patient hand. The calcium in your bones, the iron in your blood, all were once stardust, drawn together over billions of years by this same silent attraction. Your very existence is a testament to gravity's creative, persistent embrace. Tonight, as you rest, the universe continues its slow, graceful turn. The Earth carries you at 67,000 miles per hour around the Sun. The solar system itself drifts gently around the galactic center, and the galaxy sails on through the cosmic dark, all of it held in a perfect silent dance, all of it connected by the gentle universal force you now understand so well. And you are here, floating within it all, a small, warm presence in the vast, dark quiet. If your mind is still drifting among these thoughts, that's perfectly okay. Let them go now. There is no need to hold on. There is no test to pass, no lesson to remember. Your only task is to rest, to surrender to the same gentle force that guides the planets on their way. If you are still awake, you can watch the next chapter whenever you are ready. But for now, I hope you sleep well. I hope you dream softly of floating among the quiet stars, cradled by the universe itself. Good night.